Thanks for coming on this rainy night. The talk is about how to build aggregations and knowledge extraction from data. This is the typical disclosure that is just basically my perspective and not a policy, official policy or position of Microsoft. All this work is joint work with current and former Microsoft colleagues and also interns. So I'm going to give a brief introduction to the problem of reading from the fire hose, meaning reading and learning from data sources, in particular social. And then I'm going to talk about 3 projects: how to search for things to do in any city on the planet, searching the social web, and how you can generate a knowledge graph, a lightweight knowledge graph out of Twitter data. And then I'll draw some conclusions. Everything, by the way, a lot of the stuff has been published. I'll do have links to our papers if you want to read more. All the papers have all the super technical details on how these things were done. So what's the landscape in terms of social media? You're all familiar with Twitter, which is basically the place to go for microblogging. Facebook is social networks. Photo sharing is Instagram. Foursquare is an example of a location-based social network, and Quora is an example of social question answering. All these different platforms or data sources share the same commonalities, which basically they all have a social graph, mostly followers, followees. They all have recommendations. They'll recommend you friends, accounts, topics, links, point of interest. They all have trending, so there's trending links, trending hashtags, trending topics, etc. However, drinking from a fire hose is extremely hard, right? And there's very low value at the atomic level, meaning like there's very low value of the tweet, a Facebook post, a single POI, et cetera, Now, because there's a lot of human sensing on the planet at any point in time, there's a huge potential to build new artifacts, in particular aggregations. And this talk is about how we build 3 different types of aggregations. The first one is searching for things to do. So we're going to connect 2 crowds. So you are in San Francisco, and you're checking in at the Golden Gate, or you're checking in at MoMA, or you're checking in at, at this place. And then at the same time, there's a lot of people who are searching for things to do in San Francisco. This is typical. You go to the autocomplete in Google or in Microsoft Bing, and if you say things to do in, it's a city. Okay? This is like an example of that. All right. But our project in a nutshell is basically how can we use location-based social networks like Foursquare, for example, that data set, to build a recommender system. Okay? So how to use POIs, checkings, to suggest POIs of places of interest to go in any part of the planet. So but as a check-in, in case you don't know, if you're using Foursquare or you're using Facebook for doing check-ins, you check in at a particular point on the planet, you just press a button, and then the platform will record that you were here at this particular lat long and at this time. These are 2 examples of different ways of doing check-ins and what you can do with that. The beauty of check-in is there's a temporal view. And because of this, you can see different human patterns. So for example, we know that Disneyland, it's popular 365 days a year, but if you want to go to Yosemite, you have to go in the summer. So the check-ins will give you all this. And will give you human mobility, correlations with seasons, different parts of the planet, etc. Now, what about if we do that to build a recommender system? So we're going to target what we call recreational queries. So recreational queries is a common query intent. So the user is looking to perform an activity anchored around a place or a city. So things to do in San Francisco, things to do with kids in Seattle, romantic things to do in Paris. And this should be for both tourists and local users. Desktop and mobile are the scenarios. So how can we extract location information? Well, I work for Microsoft, and therefore we have access to lots of data. One of them is the query logs. So everything that you're searching on Bing gets stored in a query log. So we can go to the query logs and get an idea of what are the queries that have different patterns, like things to do, places to go, where to, et cetera, et cetera. So we can see a sampler who is going to sample different queries with different patterns. And from that, we can get all the queries that we believe contain a location. So that's the second part of the chart. And then we run a name entity extraction of locations. So then we are going to annotate all the queries with location information. And based on that, we're going to identify all the queries that contain the patterns and location data. We can do the same for other things like questions, if they're coming from Quora, URLs from the IE browser logs, et cetera, et cetera. And once we have that, then we have a massive data set of recreational queries that then we use to build a taxonomy. And that is data-driven. So let me dive a little bit more on that. So first of all, we get query logs, as I already mentioned. All the query logs will tell us a lot about popularity of cities and so forth. We have behavioral data from the browser. So we know if people using, for example, IE 11 or 10 visited a place that is a candidate for to go. And then we have the Foursquare check-ins plus the tips. So the tips are if you leave like a tip or a review on a particular POI, we can get that as well. And then the recreational query taxonomy, although this is kind of a very short screenshot, you have a query and then you have a query geographical constraint, temporal constraint, and activity preference, suitability, and other constraints on the activity. For example, you can say things to do in San Francisco, which is very specific, but also you can say things to do in the Bay Area, which is more high level. There's absolute time, so you can say things to do in San Francisco tonight, things to do in San Francisco tomorrow. The preferences are things to do in San Francisco tonight, where to go shopping, if there's an age group, if you're looking for stuff to do with kids, with teenagers. If you're looking for, if you're concerned with budget, you can say cheap things to do in San Francisco. Anyway, all those things were done mining the query logs and building this taxonomy. We call them aspects. So the other part is once we have the query classification and the aspects, then we can classify and map particular queries and point of interest as supporting evidence for this entry on the taxonomy. For modeling the POI relevance, we're using a maximum likelihood estimation, and then we're going to use temporal ranking, which is the probability of check-ins during weeks and seasons. So there are certain places that are more popular during the week, other places that are more popular during the seasons, specific seasons, as well as weekends. And then for each of these aspects, we can rank them. So we can filter all these aspects, for example, like eating, drinking, romantic, kids, etc. And with the tips, we can match this particular tip. For example, this is a good place for kids with the entry in the taxonomy that is a constraint for kids. I know this sounds a little bit crazy, but I'll show a few examples. Now, there's a problem with ranking POIs or attractions and POIs. The first one is not everything is good as a recreational query. For example, a lot of people will, for example, do a check-in at a bus station or a high school office, gas stations, prisons, etc. Not very good. We don't want to use these guys. At the same time, there's also things like a bridge, for example. The Golden Gate is a very good place in San Francisco to visit, which has a lot of check-ins, but also other bridges, in particular if you have to cross the bridge because you're commuting, you're going to be making a check-in because you're at a toll plaza or something else, as a signal to say I'm late or I'm getting there. It's not very useful to use them. The same with train station. There are certain train stations that are super popular, otherwise it's just a train station. Potentially good examples could be restaurants, churches, and parks, and obviously good examples are famous landmarks and tourist attractions. This little example, to identify those 4 categories took us quite a bit of time to understand the utility of POI. So as Alexei was mentioning, the notion of labeling the utility of point of interest is not straightforward. Once we did this, we collect labels with our UHRS, which is our internal mechanical Turk within Microsoft, with 3 ratings. If the recommendation was good, fair, or bad, we use FastRank, another internal tool. Standard TLC ranking gauge. TLC is the Microsoft equivalent to Weka. And a bunch of other features, for example, query impressions and categories and other things, like, for example, repeated visits versus new visits. And it looks like this. If you go to Bing and you say, at least when I took this picture, things to do in San Francisco. This is the recommendation. Okay, straightforward. Things to do in San Francisco with kids. In a second. Separate recommendation. You had a question?
I wonder if you could elaborate on the mechanical programs I understand that you have certain wafers, whatever they are, which have certain reliability associated with them.
So your choices are on mTurk. I cannot comment on the recruiting of people. However, it's a tool that also allows anybody within Microsoft to crowdsource. So it's not just internal editors. Anybody can get labels. Even within your team, you can use UHRS to gather your own labels.
So it is crowdsourcing.
It's yes. Yes, all of that and a bit more. Yes.
And a bit more. Huh? Is that something that you can disclose?
Not now. Not in this one.
Please repeat the question for the reporter.
Oh yeah, the question is what are the details of the internal Microsoft crowdsourcing tool? I mentioned we have UHRS, which is a comment here that we got our labels using UHRS, which is the internal mTurk equivalent. And the question from the audience was if I can share some lights on UHRS, and I said that I cannot share light on the recruitment of people who work on UHRS, but I said that you can crowdsource, you can work, and you can also hire editors. That's all I can say. All right, so this is things to do in San Francisco, things to do in San Francisco with kids. As you can see, it's a different recommendation. And we can go level up. So we're going to say things to do in California. Okay, landmarks from California. Things to do in the United States. One level up. And once we can do that, so this is how it's being used in the Microsoft Bing search engine. And this works for other cities. You can say things to do in Barcelona, things to do in Barcelona with kids. I'm not going to demo that. But here's something different. We would call urban maps. This is an internal tool, so it's not in production yet. So this is an example of Seattle. If I'm looking for things to do in Seattle at evening, that's the map of Seattle, and then it's going to highlight, like a heat map, where the activity on the city is. And then it's going to show you different places to go. So for example, if you happen to be at the Pike Place Market, you can go to the Crab Pot, you can go to Starbucks, you can go to downtown Seattle, or you can go to the Hard Rock Cafe. So it's going to give you itineraries or where to go. If you happen to, for example, do the same query, things to do in Seattle at night, or for example, places to go clubbing, the map is going to change, and it's going to show you different recommendations. And for example, another set of recommendations. So the point here is, here's an aggregation on how you can derive insights using location-based social networks, build a recommender system, and B, how can you build a different experience using maps? And we call these urban maps. So if you're in any city in the planet and you can see where the action is, depending on the day or depending on what you're looking for, you can do this. All right, so that's aggregation number one. Aggregation number two is searching the social web. This is basically, in a nutshell, how can you search within Twitter or within Facebook? The point is not for searching posts, but the point is for searching links that are being highly shared within a social network. So there's a mini web within every social network. A lot of people are calling this the like economy. Why? Because there's a lot of people liking or sharing or sharing URLs. What about if we only index that? Forget about the rest of the web, only that. All right, so we're going to build what we call a different type of search engine. As I mentioned, the idea is to take advantage of the social web structure, also called as the like economy of social buttons. If you go to a page, you usually will see a button that is like Facebook or Pinterest or Twitter or LinkedIn, what have you. There's always some social button. This particular project is links that have a lot of chatter on Twitter. We're going to extract users, hashtags, and keywords. And we're going to rank all the links based on a combination of virality and popularity. And at the end, we're going to build a Wayback machine. So how can I search in the past? So what people said at a particular event. So this is searching the social web. So you issue a query, for example, hashtag climate change. And instead of showing tweets, we're going to show what we call social cards. So the card, the focus here is on the document. As you can see, here's a document coming from LA Times. There's a picture, there's a caption, and it has been shared by 129 people. And what we care is basically not only the accounts, what people have said on those links. All right? Well, I was just trying to say that here we want the content, the people, and then we also want related hashtags. So we issued a query for hashtag climate change, but a related topic is climate, Exxon, and climate change research. This is just an example. To summarize, a social card is basically the link information on top. Trusted users, I'll explain what a trusted user is, who share the link. All the pivots that allows us to kind of traverse the story. All the posts as link annotations. If you want to explore the user, which I'm not going to show today, but we call that an operation called X-ray. If you want to explore this particular account, we can dive into the account. And it's not just the handle of Twitter, but everything that is Twitter handle has been done. And then related hashtags as queries. So the backend pipeline contains 5 main stages: the content selection, the user selection, the link selection, and what we call the final cut. And then we do annotation and indexing and presentation. So the first step, which is content selection, is a machine learning classifier that will select if the tweet is interesting or not, or is a good content. This seems like very straightforward, but actually it took us a while to understand this. So picture the following. I'll give you 140 characters, and you have to tell me if this tweet has good content or not. Hard problem. Seems very straightforward, but it's a hard problem because it was very hard to label and understand how to label tweets. Anyway, we'll have a publication on this if you're interested. But we can stamp a tweet with a score indicating that how good this particular tweet is. We do spam filtering. We normalize all the links. Then we run mini-hash for near duplicate detection on links.
Can you define briefly what does good mean in this situation?
For example, if you tweet an emoticon, low quality. If you say, I'm attending this presentation in San Francisco at, say, Domino Labs URL, you're using 140 characters, well-written, uppercase, lowercase, etc. That would be a good thing. If you use the 140 characters when we did this, was before 280, everything is a hashtag, then not useful. Everything is a single character is not useful.
Useful to a lot of other people.
Correct. So if I pick you and I give you a tweet, you say this is useful versus it's just junk. And the point is you want to index only high quality content, no low level content. And then we extract metadata, the Twitter cars, Open Graph metadata, ODP, link, classification, and a bunch of other stuff.
So what do you mean by link normalization?
Link normalization means that, for example, you have, because there's a lot of link sharing within the social network, all these links will have different parameters. So this is coming from a particular site. So you have a lot of forms that are embedded in the links because people want to track where they share the links. So we want to normalize to exactly the domain and the page. That's all. Now, a very important part is how to do user selection. You're all familiar with this notion of a verified user, which is Twitter's method for hand curating people. Now, this is not going to scale because the number of verified users is kind of low. So what we did is we came up with an algorithm that is going to automatically scale up this process to what we call trusted user, and works like the following. Works as follows. So say that Bill Gates is a verified user, and Bill Gates adds me in Twitter. I'm not a verified user. If I reply back to Bill Gates, then I'm trusted in ring number 1. So we start with verified users in ring 0, and then now I'm a trusted user at ring 1. If I add Alexei, who is also not a verified user, and Alexei replies back to me, then Alexei is now in ring number 2. So we can, this is basically an activation network, and we can scale to, what we did is was 17 million users in a few hours. So from a very small set of trusted users, of verified users, we have 17 million trusted users that we know at least they are good.
It's like Erdish number.
Yeah. There's more details on a paper. The third step is link selection. We have good content, we have good trusted, good users. Now we want to get good links. So we're going to look at all the tweets in a given period of time that contain links. For example, say that it's like doing a grep. So we're going to grep all the tweets that contains links. And then we're going to construct a diffusion tree for a link. We're going to identify, popular and viral links. We're going to run some similar link clustering. And we're going to do more filtering. So we're going to filter on English only. We're going to remove all the links that don't have any metadata. And we're going to discard all the links that only match a domain. This is interesting because in a lot of social networks, there's a lot of ad sharing, a lot of people promoting websites. We don't want that. We want a domain and a page because we want that stuff. And finally, we're going to extract what we call contextual vectors. You may find this interesting. So a contextual vector is a vector of n-grams from a set of tweets related to a hashtag or an entity. This is not a summary. It's not a summary. It's kind of a lightweight signature of a link. And the beauty of this is there's a temporal context. And you'll see later on the talk how we use this in many different ways. So for example, let's take a look at the contextual vectors for January the 7th, 2015. That's the Paris attack. So there were two trending hashtags, Charlie Hebdo and Je suis Charlie. I'm not French, so sorry if I mispronounce this. But for Charlie Hebdo, we know that the n-grams are basically free speech. Charlie Hebdo, terrorist attacks, satirical magazine, sad day, Paris attacks. For Je suis Charlie, it's kind of similar. Charlie Hebdo, free speech, Trafalgar Square, sad day, terrorist attack, Paris attack. If we look at January 26, 2016, Rogue One, Carrie Fisher, Leia, actress, princess, Darth Vader, Star Wars, pre-known. But at the same time, rest in peace, princess. Carrie Fisher, Leia, princess, rest in peace, Star Wars. More all these things in context. So the same idea, social signature. So contextual vectors, given a hashtag or an entity, will give you an n-gram. Here is given a link, same trick, okay? So here's a link from Fox News, for example, and that's the official, that's the correct URL, that's the title, and that's the signature. It's not exactly the same. So remember that the signatures and the vectors are a summary of what the people are saying when they're talking about this link, okay? So if I go back to the previous social cards, in case I wasn't very clear, if we take, for example, those 3 posts that are comments on the links, that's the data that we use to build the contextual vectors and the signatures. Okay, so it's not on the LA Times article, it's on what people are saying on the LA Times article. All right? So you saw Charlie Hebdo and Princess Laila. Now let's take a look at the first one from Fox News, the second from Politico. By the way, we don't care if you are from the left, from the right. We just don't care. That's another article on the recount. That's the title, and that's an example of the signature. And here's an example that should convey the concept. Can you identify this for me? Pretty clear. So this is the video that was shared on the Asiana airplane crash. That day, it was only a video. Now, the activity on Twitter that day basically summarized that it was a crash landing, a plane crash, a 777. Someone, a lot of people are saying that's a pilot error. We don't know. It's just on a day. It's just on this day. This is what people said. And that is basically a social signature. So we're going to use all this to make an index on those things. And by the way, the beauty of these things, for example, is if you have images or videos which don't have any textual content, the social signatures are basically the documents for those images or videos. Now the results, if we run this every day for 20 hours, if we run this process, we go, we're going to stream a lot of the content. So we start with, for example, 227 millions of tweets. The user selection, 90 millions. That's from just selecting tweets. Then we go to 44 million links, 18 million users, 15K links, 1K links after the final cut, 25 million users, 17 million after user selection, 9K hashtags, and 3K engrams. All I'm trying to say is after you apply all these different mechanisms, you have a very rich data set to build something on top of it. So instead of dealing with the entire thing, all the stuff that you don't care, which is low quality, here's a much smaller thing that you can do a lot of cool stuff. I'll show you a lot of these examples. One thing you can do is you can build a Wayback Machine. So I'm pretty sure you're familiar with the Internet Archive where you say, hey, how was my page 5 years ago? We're going to do the same thing. So we're going to archive daily snapshots. We're going to take a look at the top 50 hashtags for 2016. And we have the following scenarios. What was said on a specific date? What was relevant on a specific day? And we're going to harvest over time. US elections. If you really want to play with social data, I strongly recommend please use the US election because it's beauty. Whatever you're looking for, there's going to be an entry there. So I'm showing you two, what was said the day before the elections, the day after the elections, okay? There's no political party here. It is top hashtags for November the 8th, top hashtags for November the 9th. If you look at the top, it's just an example of 4 social cards. Mostly people are talking about, like, I'm going to vote. Maybe my candidate wins, I'm going to vote. If you look at below, is obviously Trump won. Then the media say, oh, why we got wrong? And then a lot of people say, I'm leaving the US. Typical, right? So the third one is all the actors say, I'm gone. You know, I'm gone. And it's interesting because if you look at, I'm going to highlight here, Cal exit, all right? So a lot of people are saying, let's just leave California. There was a Brexit, we should do a Cal exit. Interesting. So these are the things that, maybe the Twitter guy should be doing or the Facebook guy should be doing. But you can go back and see what was said a day on a particular day. How we do this against a Wikipedia page. So we're going to compute precision and recall against the official Wikipedia page of the US presidential election. So go. For some reason, it's not showing up. But anyway, you can see on the slides later. The official URL for the Wikipedia US elections has exactly day by day what happened. We do the same. So we're going to take a particular date. Then we're going to find our hashtags for that day. And then we're going to look up the Wikipedia entry. And then we're going to measure if these are the same or not. So if we look at the recall at 25, we're 82%. If we do a recall at 25 with filter data, is 92%. Precision at 25, 86. Precision at 50 gets better, 92%. And if we do recall at 50, it's 93%. This is completely unsupervised, so we build this thing. Although Wikipedia is editorially driven, you can also argue that our stuff is human-based because it's just written by people. So the cool thing is like they're pretty close. The last part of the talk, and I'm going to give plenty of time for questions, is how to use all the little components that I just mentioned and derive how a story evolves and how to build knowledge graphs. So here's the pitch. You can think of there's an event happening. There's a social post, a lot of social posts. There's going to be a news article and then a Wikipedia page. So Wikipedia page, in my opinion, is where the event goes to die. Okay, so the event happened, that's it. There's a Wikipedia page, shrink wrap, we're gone, what's new? Now, social posts are thousands. News are written by editors, hundreds, and then you have one Wikipedia page, which means you have the planet, you have editors, and then you have Wikipedians. So the world, millions, editors, hundreds, and then 1 or 2 Wikipedians per wiki page. So can we do better? Can we leverage this human sensing at scale and at the same time combining social and wiki? So this is our project. Our approach is basically to use a social network as a distributed human computation crawler. I'm going to say that again. Every time you're on Facebook sharing a link, every time you're on Twitter sharing a link, or LinkedIn, or Pinterest, or whatever, you're basically crawling the web for free. Okay, so I mean, We at Microsoft, there's a team who does just crawling, basically, traversing the graph to find pages. In a social network, people are saying, this is good, this is good, this is good. So let's just leverage, let's just piggyback on top of that. So we're going to extract all the links shared in Twitter that serve as the backbone of the story, and we're going to automatically build a document. Once we build a document, we have related stories, and then because people know how to read a Wikipedia page, we're going to build a Wikipedia page for it. All right? It's like this. It's a database of stories. It's a synthetic document. So what you see on the right is basically interesting because Alexei was mentioning fake news in Russia. This is exactly that. So there's an entry. Here's a story of someone obviously about the US elections and Russia intervention. That's on the right. Someone wrote an article. There's a blurb of the article. But what you see below is what we call supporting evidence. Okay, we're not claiming that we just discovered this. We just discovered this, and by the way, here's a supporting evidence for that discovery. In database, it's called provenance. Because we can do this, then we can do evolution of the story, and I'll show that. And then we have the pivots. So in Wikipedia, you have this C also. Those are the pivots. Remember when I was showing you the social card, we have related queries and related hashtags. We're going to use that to pivots on the story. And we can archive. Basically, we can archive the evolution of the story. And at the bottom, when you see references, again, similar to Wikipedia, those are all the sources that we use. So we're also going to measure how diverse our sources are compared to a regular Wikipedia page. All right, so how we do this? So we're going to harvest entire human data using two extensions. One is called Pseudo, social pseudo relevance feedback. So pseudo relevance feedback is a well-known IR technique. We're going to expand that. The same with query expansion. We call it social query expansion. And then at the end, we have a Wikification algorithm. So to summarize, we read the Twitter firehose. Then for a given topic, say US election or Brexit or what have you, we're going to retrieve all those links. By using SPRF and SQE, we're going to re-rank those links. And on top of that, we're going to build the wiki-like algo. So how does it look like? The first one is we cannot rely on just retweets because those counts are not good enough. They can artificially inflate popularity. So we're going to build a new data structure for counts. And imagine this is kind of a record. So we're going to compute counts at different level, different granularity. So there's a count for n-grams. There's a count for hashtags. There's a count for links. Those are counts at the element level. Then there are counts at connections. So if a hashtag is mentioned with a link, we're going to count that. If an n-gram is mentioned with a link, we're also going to count them. And then we're going to do counts of frequencies, the number of times it appears in the data as tweets, retweets, total, and then votes, the number of times the users who posted, retweets, retweets, and total. Anyway, the data structure is on the right, and it's basically a record that will count different things. And we're going to use this for different manipulations and different expansions. The second part is we're going to use a hashtag index. So we're going to build a table of just index that are relevant hashtags and links, and the connections between a hashtag and all the associated information. We're going to put all the social signatures there, all the contextual vectors, stuff that we already saw, and we're going to sprinkle a few tweets as provenance. So it'll look like this. So here's an example of the hashtag for hashed recount 2016. On the left, you have different entries. So December the 2nd, December the 2nd, December the 2nd, December the 3rd, December the 3rd. As you can see, the vector, the first one is Jill Stein, Donald Trump, Michigan recount. And as you go down, it starts to change a little bit because it's expected. Recount, the meaning of recount for December the 2nd was slightly different from December the 3rd, and it will be different, say, in 10 days. The same with the social signatures. The same with the related hashtags. So the first one is basically Wisconsin. At the end, we're talking about Pennsylvania. And then we have all the URLs. Okay, so you can already imagine that we can use this hashtag to start seeing how the story evolves. So if you want to know how the event recount happening, you can think of like, hey, let's have an index of all these things, and then query over time and build a story. The second is, okay, that's very cool, has all these things, but some of the things are duplicates, some of them might not be good, et cetera, et cetera. Some of them might be only useful for a particular context in time. So we're going to use this technique called pseudo-relevance feedback. Pseudo-relevance feedback, basically, you retrieve a set of documents, and based on the documents that you retrieve, you're going to take a subset of those, say, titles or abstracts and reissue a query. So we're going to do the same idea of pseudo-relevance feedback, but instead of using the content of the documents, we're going to use the hashtags. All right, so we're going to rewrite the query with the contextual vectors. So here, when you say recount on that day means Wisconsin recount. If you say recount on December 3rd, is basically Pennsylvania recount. That's a cool thing, right? So if you are fans of word embeddings, it's kind of a cheap way of doing embeddings, okay? But it's very scalable, and it's only valid for this particular day, which is what we want to do. So the initial retrieval, we're going to retrieve all the links associated with the hashtag or entity. So those signatures work for entities, hashtags, etc. We're going to rewrite the query using the contextual vectors, and then we're going to use the votes, all the votes that were accumulated, for weighting those links, and then do a final re-rank. So we have all these different links associated with recount, and we have a data structure that contains all these different votes granularity. We're going to use all these to pick the best links for that particular day. And the other part that we're going to do is we're going to find similar hashtags. So here's an example of, sorry, I told you that US elections 2016 is the best data set because we had so much fun looking at this. On July 31st, for the query Clinton, you can return Hillary Clinton, and that's a contextual vector. But the related hashtag for that day is basically Benghazi. On September 27th, same query Clinton is Clinton email scandal, and the hashtag is commie resignation. Okay, that's Democrats. Let's look at Republicans. Okay, August the 4th is Trump train, MAGA, Make America Great Again. September 16th, Trump Nation, Trump Army. The idea of these similar hashtags is you can query or you can expand about all these different things. October the 2nd, Bernie or bust, the hashtag, the most associated hashtags, #millennials. November 11th, shouldn't be Bernie, still Sanders. The idea is these two things have the same meaning, although the hashtags are completely different. I mean, unless you want to measure if they share any characters, but they're syntactically different, they have the same meaning. And on October 30th, Rogue One, that was basically Star Wars, and on 2016 is because one of the actresses and main characters of the Star Wars series passed away. Then the hashtag is Rest in Peace, Princess. All right, so that's similar hashtags. Once we have the hashtag index and all these different ways of doing expansion, the last bit on the cake is basically the evolution of the story. So we're going to start with the hashtag index. We're going to loop through all the hashtags over time. We're going to expand. So we're going to do these expansions on a daily basis. It's kind of a temporal and dynamic expansions. On a day, we expand what we have. The next day, we expand on whatever is on that day. And then we're going to re-rank the links according to social pseudo-relevance feedback. If the link is not present, we add it to the timeline. And if the link is already being discovered, then we don't add anything else. We pick another link. And then because we have all this rich data, we can automatically generate all the queries, which means that not only we build you a story, the story already has embedded all the queries that should fire the story. That's pretty cool, right? So if you're looking for Bernie resignation, we'll have that story. If you're looking for commie resignation, you have that story. And it looks like this. That's the US elections. I know it's kind of a bit blurry, but on the left, you have a table of contents that is done the traditional hit list clustering. On the middle, you have the story. That's the timeline algo that I just described. As you can see, they're not tweets. All the data is coming from tweets, but those are not tweets. Okay, so what we show is the image of the article, the blurb or the snippet, and then supporting evidence. In this case, there's an entry on Trump, and then there's Fox News that account shared that particular link, so that is the supporting evidence. The pivots are the related stories, and those are going to be the related hashtags and the topics. And then for all the sources, all those are the references, those are the domains. And this is cool because we're going to use Fox News, Politico, CNN, New York Times, Washington Post, whatever has been heavily shared on social media will be there. And all the queries are derived from the story as well as the annotations. So in a nutshell, this is a new data asset that not only we can build this automatically, but it's already has already embedded all the queries that should trigger and has all the annotations. So it's a kind of standalone data asset. So how do we evaluate this? The first one is we do an offline evaluation on defect rate. So how bad is the hashtag? How bad is this entity? How bad is this entry on the timeline? Sorry? Offline means like we'll show a blurb of the story in front of judges, like in a mechanical Turk scenario, and then we'll ask them to find if there's any. Oh, sorry. The question was yes. Yeah. The question was what do you mean by offline evaluation? I was trying to explain how we build a hit that, given a particular piece of the Wikification story, they can check if the entity is incorrect, if there's an incorrect entry, query, hashtag, etc. So they give us an OK defect rate, 5.6%. So automatically we have some issues with some defects. And then we're going to measure the diversity of the domains. So we're going to take the Simpson index, which is a well-known diversity measure from biology, and then we're going to compare our D index with the Wikipedia D index. So if I go to Wikipedia, at the end they have all those references. So we go at the bottom of our page as well for the US elections. We get all our references. We take all the Wikipedia references, and then we compute the Simpson index on both data sets, and we win. We are more diverse than Wikipedia. Then we did a comparison, a temporal comparison against Wikipedia. Now, we have few Wikipedia pages will contain timelines, so they don't have evolution of the story, just have at the end what happened. And there are a lot of Wikipedia pages that contain the needs update label. In any case, so we compare the references, that's what we wanted to know, of our timelines versus Wikipedia. We measure precision recall. Here's an example of the hashtag Harvey Weinstein, and the other one is Manchester Arena. And the coverage per day is very similar to Wikipedia. This shouldn't be a surprise because it's also human sensing. And our stories usually tend to break much earlier than Wikipedia, which also makes sense because Twitter is usually breaking news, and then it will take some time for someone to write an article on Wikipedia. So what we're trying to say is that we can build this page earlier than Wikipedia. We can even say, you can even think of like we build the page earlier and then say Wikipedia and will take over and do the edition. That will be another thing. And if we take TOC, table of contents comparisons for Sonoma fires, ours versus the Wikipedia article is basically the same. All right. So on the right, that's the official Wikipedia article. The timeline is October the 8th, the 9th, 10, 11, 12, and then from 13 to 31, because probably the Wikipedians got tired. On the left is exactly the same, the 8th, the 9th, 11, 12, 13, 14, etc. And here's an entry for October the 10th. Here's an article of the fire track, NBC Bay Area, talking about the fires in Napa. And then you have a lot of different pivots. So Napa fire, wine, Sonoma. We also have very generic terms that sometimes are not good as pivots, like breaking, for example. We know that's a problem. And then the references are coming from all over the place, from Mercury News, Google, San Francisco Chronicle, CNBC, SF Gate, et cetera, et cetera. So it's very, very diverse. All right. Now that we have all this, the rest is just basically compiling a knowledge graph. And the four components of the knowledge graph are what we call, by the way, lightweight knowledge graph. So this is not a knowledge graph of the knowledge of the planet, but just basically what was said on a particular domain. We have the links, we have the topics, we have the entities, meaning people, organizations, places, and we have time, because we dump snapshot of all these things. So we're going to look at the graph from that view. So given a link, for example, the New York Times article, then we can see who are the topics associated with this link, who are the entities associated with this link, and what was the annotations and relationships, say, on October 10th versus October 11th or November the 10th, this year or the previous year. So we have this core schema. If you're familiar with Excel pivot tables, imagine doing this. Imagine you read Twitter, and then you just basically run pivots. So you open another Excel sheet and say, just group it by users, or group it by posts, or group it by links, or group it by topics. But the cool thing is, once you build all these groups and all these aggregations, you can traverse the graph, which is conceptually very simple. Given Alexei, we can see all the links that he's shared, all the posts, and all the topics. Given the topic MAGA, we can see all the links about MAGA, all the people or entities associated with MAGA, all the links associated with MAGA, and so forth. So there's plenty of details on the papers. There's also more details on the main tables. I can't go into the other things, unfortunately, but you can imagine that once you have all this, the rest is kind of straightforward. I think I'm almost done. Opening for questions. I just wanted to show you 3 examples of aggregations out of social data. The first one was how to search for things you do using location-based social networks. The second was how to build a search engine for the social web if you only use links and annotations. And if you do that, you can build a Wayback machine, which is something that could be super cool and useful for a lot of people. Using the components from the previous project, we built a knowledge graph under the covers that powers the generation of a Wikilite document for the construction of the story. Internally, we call these stories DBs. So it's a database of stories. The shared components for the graph are basically the contextual vectors, the social signatures, the social pseudo-relevance feedback, the social query expansions, and the voting data structure. Those are part of what we call SKG, Social Knowledge Graph. And we believe the techniques are generic enough, so you can use this and say build the same at Facebook, LinkedIn, Reddit, what have you. Thank you so much for your time. I know it's late and I know it's rainy, so I'm going to hang around. Happy to answer any questions and ask me anything you want. That's my Microsoft email address, and that's my Twitter handle. Thank you. Short and sweet.
Questions, please repeat the question.
Yeah, thanks for that. I just have one quick question. So, given all the press coverage of fake news shared on social media platforms, is that a story that you saw in the data when you were reviewing that? Is that something that was filtered out when you were, people were looking at it?
Sure.
Included the 5.7% or in the earlier stage?
Let me stop this. I'm going to re-present because I knew that was coming, and I wasn't not going to present this, but I have an example of fake news. So, in a second, please. Long story short, yes, we do. We do detect fake links.
Can you rejoin?
Yeah, I know. Let me just put another slide deck and just give me a sec. It was intentional.
Yeah.
All right.
Good. Sorry.
So you saw the question is, do you guys care about fake news? And I said yes. And have you done anything with that? We've done something. So remember that I showed you this pipeline where we discover good content from good accounts and good links. So we tested our pipeline. So this is our pipeline. And I show you how to build a Wayback machine and all those things. So we're going to use our pipeline. I'm going to see if our pipeline can detect not a fake news, a fake link. Again, it's a fake link. So for that, we use this data set. It's a fake news case study. It's a BuzzFeed article, has 3 time buckets. So there are 20 real links and 20 fake links.
What is a fake link?
A fake link will be, for example, I don't know if this is fake or not, but say that Putin decided to intervene in the US elections. People believe that, and let's assume that is a fake.
A link to a news story with a fake news.
It's a fake news, yes.
But linking them itself technically is.
Sorry?
The link itself is pointing to something. but just what is on the other end is fake.
Correct. So we cannot, we don't know if the story is fake or not. Our goal is to see if we can detect that fake link in the pipeline early on. Okay? So for doing that, there's this data set available so you can download, and this is fake links on Facebook. Our pipeline is on Twitter, but anyway, we'll give it a shot. So we're going to process the data through our pipeline, and we want to know how we handle fake news. So a bit of difference from the original study. So that is Facebook, ours is Twitter. So that's kind of the main thing. The total number of shares is higher on real versus fake. So the original fake study, it says that as you get closer to the election day, there's more fake news. The number of fake news is higher than the number of mainstream news. We don't see that. We see that as we get closer to the election day, both. There's more real news and there's also more fake links. Okay? But this is kind of the cool thing. How we're going to process the links? So we're going to start in 4 steps. So step 0 is we just kick off. By the way, to clarify, there are 3 buckets: February, April, May, July, and then August election day. So February, April, according to the data set, is low on fake news. As you get closer to the election day, goes higher. Early on, high good news, and as you get closer to the election day, there's more fake than real news. So we have 4 steps in our processing: the content selection. Remember how to select good content, how to select good users, how to select good links, and then the final cut, we call it that way. Those are steps from 1 to 4. So here, the blue is real and the orange is fake. So if we look at February and April, we cut basically the fake links in step number 3. So in step number 3, we were able to get rid of most of the fake links, and then by step 4, they're not fake links. Although the number of good links, lowers a little bit. If you go to May, July, pretty much the same. By step 3, we get rid of most of the fake links, and step 4, all of them are gone, although we lose some of the good links. And as we get closer to election date, although we do remove fake links, we still have a few fake links. So most of the fake links are not viral enough to be selected. So they don't populate through our structure enough. We weed them out early on. Now, if we get closer to the election, it gets much harder to filter out fake links. This could be because you may be a trusted user, say CNN, sharing a fake link. And still, the step number 4 reduces the number of fake links pretty good. So we believe that with the pipeline that I presented, if you're in the business of detecting, say, fake content, you can do this early on. Even at the link detection, without even spending resources on detecting if the story is fake, you can already cut this link early on. At least you can label as a potential fake link. And you can fine-tune parameters, run more optimizations. For example, for the content selection, we could say we need 200 shares per link. So we're going to put a bit of a threshold for users. So we want 1 verified user and 5 users from trusted users up to ring 2. So verified, Bill Gates, myself, ring 1, Alexei, ring 2. And link, for example, for the link selection, we can play with some of our virality scores. And even if we do that, we still get a few links at the end, but we remove the fake links way, way early on. So much earlier than here. So in step 2, most of the fake links are gone. So if you want to do this at scale, again, saves you a lot of computation time. We don't do this on Facebook because we don't have access to Facebook. I don't work on the spam detection team, so I cannot comment. But we are in the business of detecting fake links, spam links, etc. Any other questions? Yes, sir.
2 things. So you don't use it on Facebook. I assume you're using a fire hose from Twitter, or are you using a public social that
I don't know today, but we used to pay for the fire hose. So
now you can just crawl. I think like Bing does, like Twitter, Google does, but they can just crawl static pages that come up. Because Google, I mean, Twitter puts up static pages after people post. They each have unique URLs, so you just crawl them fast enough.
So this project is based on Firehouse access. So we, at least at a point in time, we did have access to the Twitter Firehouse. Everything is assuming that we have access to the Twitter Firehouse.
What's this? Go ahead.
Is this project, does it cover only news, or do you do economy as
So the question is, do you cover only news? We're just, for the two projects are mostly about human sensing. Human sensing means you either tweet or write a post, but you also have to do a lot of sharing. Regardless if this is news articles or a video that is going, with dogs and cats, we just only care about large-scale human sensing. I hope that answers the question. So it's not about specific domains, about large-scale human sensing. Yes, follow-up question.
Is this idempotent in the sense that every day you run this?
Runs every day.
Able to repeat this, are you able to consistently get the same results?
Well, the thing, let me see if I have this. I'll get back to this in a second. The social knowledge graph, which is basically 4 components: links, topics, entities on a day. But every day you timestamp this graph. So it's not a single graph. So every day there's a snapshot of the graph. But because it's snapshotted, then you can go back in time and build aggregations. That's how we build story evolution. That's how we can build this Wikipedia page. That's how we can build a Wayback machine. So it's not a single graph. So there's no like a graph. It's every day there's one snapshot. Maybe today there's less activity than yesterday because maybe people were talking or sharing more yesterday than today, or maybe tomorrow. But that's the thing. Every day you dump a copy, and then after that you build aggregations. So you can build, say, the weekly view, the monthly view, the year view, the decade view.
But a question, but maybe a stupid question, but you do your aggregation on the cumulative graph up to today, or only on what was today. You're working with deltas or
We don't, so the question is, do you guys do deltas or accumulate? This is kind of a building block, so every day it's just a snapshot. Mm-hmm. If you want to build something, because it's an internal graph, you have to kind of parse whatever part of the graph you want and then build whatever aggregation you want to build on top of it. So if you need a delta, you have to build that delta. If you need, say, another aggregation on top of it, you have to do it. I just described the bare raw view of the graph.
I think Firehouse is real-time information inventory, so it doesn't give you historical data unless you missed a window.
Yeah, but so you basically have a window and just aggregate everything inside this window, right?
Right, because the hashtags give you metadata way to watch it drift. Because by you building static pages off of the change of your metadata hashtags, the tags, the descriptive tags that come off the tags, you auto kind of build a static. You've got a static index, but then you also have a dynamic one to show the drift of the change.
You could. You could. I'm not saying that you cannot. I'm just saying that the way that we've done it is we kind of download a copy.
Oh,
Okay, of what we believe is the knowledge graph for today. Yeah. Tomorrow is different. Yesterday was also different.
Basically, what I'm saying is because by the way you structured it, it automatically gives different one each day.
Correct. Yeah. Yes.
Yes.
I was wondering about the order of filtering. You filter content first, and then you filter by the trusted users.
Yes.
And it lets you take the verified users and 2 rings.
Yes.
And the numbers drop very significantly between the orders between the content and the users.
Yes.
And what would it be? I compared it. You selected users first and what they wrote, and then filter by interest and add that. I understand that you would miss a few things, but then if they weren't in the 2 trusted circles, they wouldn't make it into the selection.
Correct. So the example here is why we're if I can understand the question, why we're dropping some of the good data, although we're using trusted users?
Just the order. Why do you do content first and users after? Because the order drops so much.
Oh, content goes first because we want to see if it's just the order of, that's a good observation. It's just the order of how we build a pipeline. Because the content selection here is all the tweets. We cannot, we don't want to process and run all these things in, for example, 230 million tweets. We want a subset of that.
That's actually not such a big drop. It's the other one.
Okay. So think of like, tweets, links, user, hashtags, and engrams. And in every phase from content selection, links, user, link, and final cut, we always kind of get less and less with the assumption that is good. Yes, we're going to lose a few things, maybe good things, but it's just the way that we build
it.
it.
Makes sense. I thought it is 18K, and in this case, it will be an interesting question. If say 18 million, then the scale is not so big. It makes sense.
Is it like probability models, or do you infer more facts about like where the world?
So the question is, if we do more complex stuff to infer different things about the world, no. This, at least in this project, no. It's very, very simple, in the sense like, think of this as like a massive filtering at scale. Once we have this in place, which took us some time to build, the rest you can run all those things. You can do, fact checking and a bunch of other stuff. I don't have anything to show at the moment on that.
Yeah, I was thinking about the first part of the talk where you were saying that you infer like there's like some hierarchy of California, San Francisco.
Oh, that's for the things to do. Yes. Sorry, I thought you were talking about the Wikipedia. Can you repeat the question again?
So can you we did something similar for medical data before, not here, and it basically was like inferring certain facts through like in this pathology.
Sure.
And it was like wondering who was prototyping to use like probability graph models to infer certain facts.
Okay. No, for the things to do is mostly location expansions. Okay. So we're just using some formulas from math on.
Kind of like expand radius.
Yeah, that kind of stuff.
Oh, okay.
So the fact that a POI, is in a radius of certain miles or kilometers, then we'll just derive another city or another place, state, county, country, that kind of stuff.
So specific to
The domain of,
recreational-
yeah, it's mostly geolocation.
It's not like semantic.
No,
kind of
it's-
like terms abstraction.
No, the question is, it's mostly about geocontainment. Okay, so we don't derive any, the question is if we derive anything specific. No, we don't. It's mostly geocontainment. Alexei, yes.
So I remember you mentioned n-grams, right? So you derive n-grams characteristic of a tweet.
Yes.
So talk a little bit about it. Are they normalized? So like, how do you make sure that different tweets produce similar n-grams? Like I tried to normalize n-grams from tweets, so you just compute all the n-grams and select some.
It's all about volume. So let me see if I have the voting data structure here. It's mostly about volume. So when I say normalize, it's mostly normalizing that they are clean, they don't have any problems, and then we just count all the, sorry, I don't have it. It was on the previous one. No, it's here. We just basically normalize all the n-grams like just a term, a token. And then we graph for that particular thing, everything that we can know about the term. So if the term is Trump, it's a term, but also is an entity. Clinton, it's an n-gram, but it's also an entity. We also do other things like, it's not here cash tags, so $MSFT, it will be Microsoft in terms of financial information versus hashtag MSFT. So it's basically kind of taking the 140 characters and kind of fine-graining counts on different elements of the tweet, basically, at different levels. And because we do co-occurrence, then we know that hashtag mentioned with the link, link mentioned with the entity, link mentioned with the n-gram, and so forth. And then counting.
So then you can basically characterize a tweet by the most common, like you can pull like trigrams.
You
Right?
could,
And for each of them you can pull out the tweets represented by.
for example, yeah. Question at the end? Yes? Well, we use it. This is a researchy, yeah, this is a researchy prototype. Part of the graph is there on the spotlight. If you go and a big news answer will be part of the stuff is powering the rundown. The rest has been mostly a prototype on how to build knowledge graphs for internal consumption.
It's maybe for internal use.
Yes, it's basically, it's another data asset that can power other Microsoft properties. So I know when we show these, people say, are you going to build Wikipedia? No, we're not building a Wikipedia. We're not externalizing any of those pages. It could be cool, but it was mostly for us so we can understand how good the content was and which were the problems in parts of the graph.
Google required a knowledge-based company, like, got the name of it, that ex-Google guys who built like a tool that let people auto-generate or placed in by hand stuff to help tune Google search. So I mean, it's a really good approach to use it, to have, especially in an area where we don't know what the value of data is. It's an actual open source project or a project coming up. It's going to open source soon on the overweb. It's called Bridget.io. Be able to look at that because it lets users put their own opposition or support of the accuracy of some data and distribute it.
I'm not quite sure if we can upload data there, but I'll take a look
Yeah.
at the website.
It's early. They just want to EU future web award. They help distribute stuff for the Internet Archive and Congress.
Okay.
Interesting approach of trying to give people access to be able to score accuracy.
All right, I'll take a look. Yes.
So for these cases, I think evaluation is hard, but the assumption is that this knowledge graph actually does have all the information, like Twitter, everyone is sharing. Like, how do you know that this fact that you have all the information related to this?
So the evaluation is very, very hard.
Yeah.
Okay. And so the question is how you evaluate this type of assets. That's kind of a generic question on how you evaluate domain-specific graphs. I don't have a good answer to that. The only thing I can tell you is that the only way that we do the evaluations is on specific cuts of the graph. So you may want to evaluate the users. You may evaluate the links. You may want to evaluate the topics. So just showing the graph in front of people is like, what the heck is this? So what you do is you query the graph, you get some data, and then you build an evaluation on that particular angle of the graph. And then if you have many, many nodes, well, just pick your nodes and then you iterate. So you know that, for example, we're very good at users, but we have some problems for example, in this project, we have some problems with certain hashtags. Like I show you breaking. Yeah, it's a very popular hashtag, but everybody's breaking. Hash news, not really good. So we know that we have some problems there. In users, we don't have usually problems. In links, we're pretty good, but in certain hashtags, we do have problems. And the only way that we found that out is because we just evaluated on item by item on the graph. Now, obviously, this won't scale if you have like very complex knowledge graph, but this one are what we call lightweight knowledge graphs, 4 or 5 main entry points. So then it's more manageable. But it's a hard problem. I don't have a good answer.
Yeah. But one other question though, this may be not too relevant, but in the beginning you showed the things to do and things to do with kids. What is the distinction between things to do with kids? Like it was calculating the sciences, the things to do with kids, but then things to do, there was Golden Gate Bridge, but I think kids might
Sure.
have done that as well.
Hold on. Let me bring that up and then we'll, sorry for changing, but yes, hold on. Because I don't have I have things to do only on this one. So, give me a sec. So you want to know why we change things to do. Okay. I'm presenting again. I'm getting good at this. Okay. Okay, so the question is, so here's things to do in San Francisco, and the first one is Golden Gate. And I think you're saying why we're not showing Golden Gate, right? Well, the reason is because all the things that you see on the bottom, those are POIs that have annotations that are for kids. Okay, so that's what we build. Maybe I was going too fast. When we build this classifier, we have different aspects. So you got all these different constraints on the taxonomy, and then you have the POIs. So if the Academy of Science has a lot of tips about kids, okay, and then you're looking for things to do in San Francisco with kids, if you didn't say kids, Golden Gate goes up. But because you say kids, if Academy of Science was number 20, now is on top, okay? And the way to do that is to leverage the POIs with the annotations. The annotations are the tips. That's what we do. We can do romantic things to do, that kind of. Obviously, we don't have all the aspects because some of them don't have a lot of data. But that's the point. So if you say things to do in San Francisco is one recommendation. Imagine with kids is a filter on top of that recommendation, okay? And all those things do have a tip that says good for kids, good for small kids, lovely day with the kids, all that kind of stuff. Yes, that's the, and this is for the other gentleman, this is geo-containment. It's basically moving up, moving up. And works for Europe as well. So there's a CIR paper, and then there's a demo at ICWSM where we show all these things. All right. Oh, you got a question? Yes.
So you want to elaborate based on your experience. Was this technology best suited for application, for a type of application? You mentioned fake news. You mentioned that it's more than fake news. And also, how far do you think this is for commercialization?
Well, the first one, which is things to do, is in production. So this, I show you this already in production. For the fake links, that data asset is used at Microsoft mostly to identify hashtags, related hashtags, links. The Wikipedia example is just an internal demo that we put together, but the value is on the graph that powers the applications. I was just showing an example that if you build this knowledge graph, then these are two examples. So the Wayback machine, that's an example. Searching the social web with the social cards, that's another example. All these are examples of this. This is a search in Twitter from a different perspective if you have a graph, okay? So maybe you would like to see examples from Facebook or Twitter or Pinterest this way. We're not claiming they have to do it that way. But here's what we've done is basically we read a social network data and then we spit out a graph. If you spit out a graph, then you can build these kind of applications on top. That's all I'm saying.
Like they've done moments. Actually, what you just about to say, Twitter's come up with moments around terms.
Moments are editorially driven. So moments are, my understanding is editorially driven. So someone make sure that the moments are okay. This is fully automatic. Everything that we show here is completely unsupervised. Feel free to take the pictures. Yeah. That's in a Web Science paper a couple of years ago. Yes. You have one question? Yes.
Can you tell about your choosing these first round users? Because it seems like this algorithm of choosing, of ranking the users, it's pretty biased. And related to this first group of users with round one.
Okay. Trusted users?
So how do you enter it?
So the idea of trusted users is the following. So imagine you want to read, say, Twitter. You want to read content from, quote, quote, good people. Okay, so how do you know they're good people, meaning good accounts? One way is to go and only read content from verified users. Bill Gates, Barack Obama, Donald Trump, etc. That on itself is already biased, all right? And we'll have a lot of companies, CNN, Microsoft, they're going to be there. If you want to get like average Joe or like regular people, you have to scale. And one way to do that is to use this technique that we call trusted users. And we can go up to ring number 10, and that's where we stop. There are many other ways of doing this. It's just one technique, one design, but the goal is, no, we went up to 10 because we couldn't find better content after that.
Another question, how do you, your content filtering is rule-based mostly, but without some modern learning vectors?
No deep learning here. This is nothing against deep learning. There's no deep learning here. This is mostly heavy on information retrieval, data mining, and also ML. Machine learning is mostly for the detection of good content.
Yeah, I mean, you
So-
choosing that content is good by some rules, like it has.
No, it's a machine learning model. So the ML model will tell you if the content is good.
So what kind of model you're talking about?
It's a support vector machine, if I remember correctly. We use a lot of different features like who is the user, number of hashtags, ratio of hashtags versus regular terms, presence or absence of a link, etc., number of ads. There's a paper I can point you to, has all the details of the classifier. But basically, the ML model is the selection of the content. This, you can, if you want, you can build a machine learning model, but this is more of an activation network, okay? You start with the seed, again, it could be labels like super good users, and then voila, you scale. The viral link detection, this is mostly about kind of looking how the link goes through different viral structures within the graph, and then we're trying to pick links that are heavily reshared. It's mostly about activity. And the other one was the vectors. You mentioned embeddings. It's kind of a cheap way of doing embeddings. Okay. The reason why we didn't do embeddings in general is because these are super fast to compute. These are just basically counters. And the same technique works for the hashtags and also works for the links. We don't have to train, we don't have to retrain, there's nothing. It's just like, it's basically a grep, and then signatures also using some other models on the hashtags, the topics, or the links.
And how long the training?
Which training? The ML model for the question is how long does it take to train? We don't train. The ML model for the content is done. So we basically, every day we build the graph. So it takes a few hours to build.
Do you label your own data? Or?
Yes, we did label our own data. That was extremely painful. We can talk. I gave the talk at the Data by the Bay a few years ago. How difficult it is to label tweets. In general, how difficult it is to label social data. So if you're interested, we came up with a methodology on how to label complex data sets. Okay, so the example is I show you 140 characters and you have to label this. And it's very, very complex. However, if you can label some of them, then you can just build your straightforward machine learning model. But the key is how to label social data, which is hard. Labeling Facebook is hard. Labeling POIs, location-based social network, is hard. Labeling your LinkedIn profile is going to be hard because you're the only one who can label that, et cetera, et cetera. So labeling social data in general is very hard. And if someone tells you that they have a super cool, high inter agreement labelable data set from social, don't believe them because it's very hard. Very, very hard. I can point you to a few examples. Yes, sir?
How do you guys think about expertise in extremism?
Yes. Expertise. We did something on expertise. I don't have anything to show here. But we did, and I think we have something on how to do expertise detection from social networks. So the way of how expertise detection is done is the number of times you mention a topic or a hashtag, that's your expertise. If you mention a lot deep learning, then you're an expert on deep learning. So we extended that model, and then we built another thing, which is not only what you're tweeting or writing on, say, LinkedIn or Facebook, but what people are tagging with you. So if people are tagging you with certain topics, that is also included as part of an expertise model. Unfortunately, I don't have anything to show today, but if you want to talk offline, yes, we've done something on that.
One quick one, if you have somebody else. What did you think about the API that Cloud had around tags and expertise, how they would validate against trending posts and show you the posts that people were trending on in a sub area, so you can kind of validate against their API, look at the data API before letting you make them to them internal.
So we used to have access to cloud data like 6 years ago. I believe Microsoft was an investor or something.
Yeah, it was, that's right, yeah.
The problem with cloud, I remember we have certain things that were kind of off. I remember Tebow, the former NFL player, was tagged with things that were not appropriate for football. So it was a little bit hard to gather expertise on that. So we've looked at it and we decided to do something a little bit different. But we did look at cloud data for quite some time.
Yeah. And using like data like Bitly did for a while, it would show you reposts of tags, reposts of information around the world, timestamp, and also location stamp, and show you responses off of links.
Yeah, but the percentage of geotagged tweets is kind of small.
Yeah.
So, yeah. Any more questions? If not, I'll be around until 8:50 because my parking ticket is 8:51. So I have 1 minute to go and grab my car, but I'm here for 48 minutes. So.
Yes.
I'm still thinking about temporal aspect. So when you tag hashtag, for example,
Yes.
there could be hashtag which is very popular today and not popular tomorrow. And there could be persistent hashtag which was popular today, tomorrow, and the day after that. But if you just do it in a window, one-day window, you wouldn't see this persistent hashtag, right? You would classify it as popular hashtag.
We need volume.
Yeah.
All right, so say that you have the hashtag XYC was very popular today and then disappears.
No, I'm saying that it was relatively low popular, but for long time.
Oh, okay. This presentation is mostly about volume. However, our graph, you can also build what we call domain-specific graphs.
Mm-hmm.
So then you can lower the thresholds,
Mm-hmm.
and then you can get stuff that is has a lot of volume, but it will gather these things like XYC is consistent over time, which is basically what you want. This particular presentation is mostly on high volume, but the techniques work for that. You can choose, it's basically a configuration file.
So you mentioned about you have some publication about this.
Yes.
So
Sorry, it doesn't show here, but
could you share somewhere
Yeah.
in the bitmap or GitHub?
So, sorry, let me just go one by one. See if you're asking. Doesn't show up here. So this is one of the papers, Web Science.
Okay.
They're all on the web. If not, shoot me an email. I'll send you the copies.
Okay, probably I'll contact you through the meetup.
Web Science, then we have the activation network is IWSM. The story evolution, we have 2 papers on story evolution. There you are. JCDL and IWSM last year.
Do you have any publication about expertise identification?
I have an old publication on that based on the Apache CVS logs many, many years ago. We don't have anything new on that published. I mean, we've done work, but can't say anything at the moment.
I remember this GCDL presentation.
All right, thanks for coming.